Hi everyone, my name is Engine Cadet Aligway and we are Group 3. So together with my group members, Engine Cadet Ababa, Engine Cadet Idon, Engine Cadet Ihalad, and Engine Cadet Patlingrao, we will discuss to you a 10 critical machinery equipment inside the engine room. So we will describe to you the use of each critical machinery equipment and explain why is it considered as a critical equipment. So we will also state the allowable minimum required number of spare parts of each critical equipment. So the 10 critical equipment that we choose are we choose to discuss are the main air compressor, emergency compressor, control air compressor sets, main and auxiliary engine circulating system pump sets, main and auxiliary engine system filters, HFO and lube oil pumps, feed water system pump sets, boiler circulating pump sets, boiler safety valve sets, and the rudder, shafting, and propeller systems. So we will start at the main air compressor. So what is the main air compressor? So the main marine air compressor acts as the power source for starting primary and auxiliary engines. Main air compressors is used to supply highly pressurized air to start main and secondary engines. Air compressor has an air storage bottle which stores the pressurized air. So there are available different capacity of kanang main air compressors, but this capacity, guys, should be adequate for starting the main engine. So it can be released when the engine start. So air compressor can be of various types. So, and they include the centrifugal compressors, rotary vane compressors, rotary screw compressors, and reciprocating air compressors. So ang ship may have 2 or more main air compressors depending upon many factors such as each air compressor capacity, amount of volume or air needed from starting the main engine, demand of air on that particular ship. So why is it considered as a critical equipment? So the main air compressor is the heart of the air line on board. The air compressor compresses air by means of reducing its volume so as to raise its pressure. So the main marine air compressor stores pressurized air so it can be released when the engine starts. So this compressor is typically at a high capacity since starting the primary and auxiliary engines required to a significant amount of power. So on board ship, guys, compressed air is used for several purposes. So on the basis of application, different air compressors are kept for particular usage. So air compressor is used to provide to start the air to various machines and main engine. So other than the main engine, so other systems also require compressed air. So daghan pa kayo sa machineries nga to nga manginhanglan og kanang pressurized oil. So anak importante ang main air compressor, and that's why it is classified as critical equipment nga to. And if kanang planned maintenance is not carried, guys, out in time, so efficiency of air compressor will drastically reduces because of excessive wear in the components. So ang result is the compressor will not keep up with demand during the maneuvering. So this may cause overheating, vaporizing lube oil, increased wear down, and possible explosion. So guys, and if the main air compressor is stop working or there's something to fix in it, we have to make sure that we have an emergency air compressor to take over the job of the main air compressor temporarily. So for the meantime nga guba ang atong main air compressor, so dapat na jud tayo naka-reserve nga kanang emergency air compressor. And now we will also talk about the emergency air compressor as a critical equipment on board ship. So, what is the emergency air compressor? So, the emergency air compressor is a small independent air compressor which can be either driven by an independent prime mover like an engine or having a power supply from the emergency switchboard. So the emergency compressor is also just like the main air compressor. It is used to fill up the emergency air bottle which has a sufficient volume of air to start the auxiliary engine of a dead ship. So ato makuan nga ang emergency compressor is a reserve jud siya nga compressor. So if ever nga maguba ang main air compressor, natay ang emergency compressor nga magamit para dili ta mo kuan og kanang wala tay delay sa barko. Samot na kung schedule na to nga kana nga oras is mularga na ta nga barko or mo depart na tagikan sa pier sa certain area. So dili ta ma-delay kay we have an emergency air compressor man nga ni take over sa responsibility sa main air compressor. For the meantime nga giayad pa ang main air compressor. So why is it considered as a critical equipment? So emergency marine air compressor provides a backup power source in case of an emergency. And in a potential power failure, this compressor can provide the power necessary to operate the primary and auxiliary engines. Having at least one of emergency air compressors on board is crucial to maintaining the ship's function. So just like what I've said to you earlier nga, gamit kayo ang emergency air compressor and crucial siya to maintain the ship's function para dili ma-delay ang operation sa barko. And sa other concept guys is kanang concept guys. So other side nga importance sa emergency air compressor is nagoy gitawag sa barko nga dead start or a first start arrangement. So totally ang barko is dead and no any power and no machinery is running and no compressed air in the air bottle to start the generator engine. So then provision is given for every ship to get the air bottle filled to bring up the ship to safe, normal, and working condition. So this is provided by either the emergency air compressor driven by a small diesel engines or electric motor getting to its power to supply from emergency generator. So mo na siya guys nga kanang ang reason nga nung nahimo siya nga critical equipment sa barko. It is because of that emergency air compressor is the substitute in case nga maguba ang main air compressor. And if the main air compressor will di sad mo operate or di sad mo function og sakto, then magdungan sila gaguba, then mo nagingon nga nadyo ka sa big trouble. And that's all.
Good day everyone, I'm Engine Cadet Yaz Eberson Ialad. I'm about to discuss what is air compressors controls. Air compressors control are designed to match air compressor delivery with compressed air demands by maintaining the compressor discharge pressure within a special range. This discharge pressure should be set as low as possible to minimize energy use. Control strategy to need to develop using a system approach, taking into account system dynamics and storage. There are 6 basic types of individual compressors controls. First is stop or stop. Turns the driving air compressors on or off in response to a pressure signal. Circulating and rotary screw compressor. Second, load and unload. Allows the motor to run continuously but unload the air compressor when a predetermined pressure is reached. The air compressor loads at predetermined lower discharge pressure. This type of air compressor control is also known as constant speed or constant control, reciprocating a centrifugal and rotary screw compressor. Next is modulating. Restricts inlet air to the compressor to progressively reduce air compressor output to a specified minimum, at which point the compressor is unloaded, also known as throttling or capacity control. Next is dual auto-dual. For small reciprocating compressor, allows the selection of either stop or start or unload or load, or dual auto-dual provides modulation for lubricant injected rotary screw compressor to a preset reduced capacity followed by unloading with the addition of an overrun timer to stop the air compressor after running unloaded for a preset time. Next is variable displacement. Allows progressively reduction of the air compressor displacement without reducing the inlet pressure. Reciprocating multi-step and rotary screw compressor turns spiral or puppet valves. Next is variable speed. Adjust the air compressor capacity by varying the speed of electric motor driving in the compressor in response to system signals. Next topic is main and auxiliary circulating system. The main condenser, main lobe oil cooler, and the Nash vacuum pump are supplied with cooling water by the main circulating system. When the ship is underway with sufficient speed, water may be circulated by a scoop injection. However, when the ship is maneuvering operation at low speed or in port, the main circulating pump must be used. The auxiliary circulating system supplies cooling water for the auxiliary condenser, the auxiliary lobe oil coolers, and the air coolers. A cross connection between the two circulating systems is provided for emergency operation, and the main circulating pump made to pump the engine robe bilge in emergency. So that's all for my report. Thank you.
Hello everyone, I am Engine Cadet Ababa and I am here to discuss about the main and auxiliary engine system filters. So on board ship, we can encounter 4 types of filters. So there are 4. So first is the hydraulic filter, second is water filter, third is air filter, and lastly is the special filters. So under the hydraulic filters, there are fine mist screen filters, magnetic filter, auto backwash filter, and centrifugal filters. So in the water filter, we can encounter the switches, strainer, fire line suction filters, bilge line filter, and freshwater system filter. Then in air filter, we can encounter the control air filter, turbocharger filter, then IG system scrubber filter, and compressor filter. Then in special filter, we can encounter OWS first or second stage filter, the oxygen analyzer filter, and cartridge filter. Next is the FHO and LO pumps. So we can also call this the marine fuel oil transfer pumps. So these pumps is used for fuel supply to fuel consumers. So the most type marine fuel oil supply pump is the marine gear oil pump, marine oil pump. So it can be in external gear oil pump, internal gear oil pump, and circular arc gear oil pump. Marine gear oil pump has compressed size, low cost, and reliable performance. It is particularly suitable for fuel oil transfer for high or heating jacket by hot water steam is available.
Hi, so I will discuss about feed water system pump sets. So at the value of feed water pump sets, they are corresponding to the turbine design quantity and quality. So the head produced by the pump is in the excess of that required to pump the water to the boiler. So it is normal practice to design the boiler to produce a higher rate of steam to generate than the appropriate of the value in the turbine generator design. So to the effect of the turbine, there are the feed water flow that needed by the normal boiler. So there are specific conditions. This is intended to cope with pump wear and transient and conditions. So to act as an operational margin, when large pumps run, they create a great deal of heat from the churning effects. So when the pump runs, it is necessary to cool the pump impellers during a higher load operation. So fluids through the pump acts as a coolant or a cooler. So when the pump just starts or when the pump recirculate, so the fluid through the pump will define as returning the pump discharge flow. So to the point ensured where the pump has a suction so that a minimum flow of requirements of the pump is from the ensured of recirculation flow. So the pump entirely or partially flow water from the BFP. So it is returned to the deaerator in the startup at the low load. So generally, the BFP handles the high flow at the high differential pressure. So the pump sizes are large, so even for small units, such recirculation flow is very necessary. So, as the power requirement of a boiler feed pump of a typical 500 MW unit is approximately 10 W. So, it can be seen that the choice of an economic and technical acceptable variable speed boiler feed pump drive is a decision or a major importance that could possible boiler feed pump drives which has been considerable with the CEGB for use on a large generating units or large vessels. So there are three. So one is fixed speed electric motor with variable speed coupling. Second is converter fed variable speed or electric motor. So fourth or the third is back pressure steam turbine, and the fourth is condensing steam turbine. So in addition to the option of slip ring induction motors regulated by resistance in the rotor circuit, so it has been considerable and used in the past. So this relatively cheap and also simple in having a solution or a rectifying any liquid with mechanic usage. So movable tapping points has proved unreliable in practice, which is a high maintenance burden to the workers. So next is the boiler circulating pump sets. So how do I know if my boiler circulate pump is bad? So common indicators that your boiler pump is not working: unusual noises coming from the boiler, such as constant hum, or the pump is running but the water flow pipe is very cold. So water is leaking from the pump and there is a no hot water at all. So your pump is constantly running and won't switch off. So the rise in total generation capacity of renewable energy sources such as wind and solar is resulting in traditional baseload coal. Generally, plants being more frequent today used to flow fluctuating electricity demand. So also called peak load operation. That's what we call. So this change in operation has an effect to the conditions or the power plant equipment, since machines are very now subjected to the operating conditions. So they were not originally designed to the term baseload, so they are usually to plant operating as a stable electrical output for a sustained period of time. So this is typically at the near of peak efficiency. So what it means for the boiler water circulating pump or BWCP is the plant is there a having a minimal thermal cycles and hence minimal cyclic thermal stress. So the equipment can be operated at a stable and very constant condition rather than frequent being started at a stopped or ramped, and yeah, constant condition rather than frequently. So the pump case on a BWCP is welded or into the pipework and typically made from the thick weld. So the frequent thermal stress of cycling can present problems and also fatigue crack, development at critical regions such as thicknesses, nozzle, connection to the motor, and also operators should inspect pumps cases for any reasons like development and propagation of the cracking. If the pump case welds are not part of the maintenance, the program associated with high energy pipe work, so it is needed that they should be included in the periodic inspection of the pump cases.
I am Engine Cadet Idon Arbel, and today I am going to tackle about the boiler safety valve set. Often considered the primary safety feature on a boiler, the safety valve should really be thought of as the last line of defense. If something goes wrong, the safety valve is designed to relieve all the pressure that can be generated within the boiler, and the required valves per boiler is 2 safety valves per boilers are required, and a third may be needed if they do not exceed the MFC. There are 3 main parts to the safety valve. This is nozzle, disc, and spring. Pressurized steam enters the valve through the nozzle and is then threaded to the boiler. And for the rudder is a primary control surface used to steer a ship, both submarine, hovercraft, aircraft, or other conveyance that moves through a fluid medium, generate air or water. And on an aircraft, the rudder is used primarily to counter adverse yaw and P factor and is not the primary control used to turn the airplane. And for the shafting consists of propeller shaft, tail shaft, and intermediate shaft. Propellers are normally built of bronze and shafting of forged steel, and conventional propulsion system can be categorized in following components for given ship speed. If diameter of propeller increase, frequency of revolution decrease. And for the propulsion system, the propulsion system on a vessel can be as simple as a diesel engine directly connected to a propeller shaft, and which drives the propeller, or more complex system containing diesel engine powering and electrical generator and supplying electrical power to an electrical motor through sophisticated control system. And that's all.